Basically what this section is, it just has like a couple different examples in it, but it's not really new content. It's still about dilation, scale factors, similarities. Everything is still exactly the same. So it's really just, let me show you a few different examples. So we are on the 7-6 note page, not the segment partition page. This page that you have on your desk is what we're going to do after we go through these short notes. This is a separate framework that we are required to go over in geometry. And so we're going to talk about how this relates to what we've been doing, okay? So I just have a separate little page of notes for that. All right, so basically this section is just going back over what we've been doing. I just want to make sure that the questions you see here don't affect you on the test. So it says, draw the border of the photo after a dilation with a scale factor of 5/2. So first of all, should our picture get bigger or smaller? Bigger. 5/2 is greater than 1, so it should get bigger. If these are the coordinates of my original picture, and I want to draw just the border, we don't have to get crazy and draw this picture of the horse unless you just love to draw. If I want to draw my new border, what am I going to do to each of these coordinates to find my new coordinates? Multiply them by 5/2. Remember that your scale factor tells you what to multiply by. So let's go through here real quick and list what the coordinates are. So what are the coordinates for point A? 0, 0. What's going to happen when we take 0, 0 and multiply it by 5/2? It's going to stay 0, 0, right? So this point is not going to change. This we can go ahead and relabel A prime because it's going to stay where it is. That is going to be the center of the dilation. The picture is going to get bigger from there. This point is not going to move. All right, D, where is D at right now? Careful. 3, 0. Remember, it's always X, comma, Y. And we're going 3 on the x-axis. So now let's find D prime real quick. We're going to multiply 3 times 5/2. Bless you. What is 3 times 5/2? 15 over 2. And what is 15 over 2 if I want to graph that? What is 15/2? 7.5. What is 5/2 times 0? 0. So this is 15/2 0, or if you want to write it as 7.5 0, that'll make it a little easier to graph. On your picture, you don't really have enough room there, so we're going to go out a little bit further. Let's keep our tick marks going. Here's 5, 6, 7, 8. And we're going to go to 7.5 and put D prime. Okay, let's keep going. Where is B currently at? Good, 0, 4. So let's go ahead and find B prime. If I multiply 0 times 5/2, what do I get? 0. If I multiply 4 times 5/2, what do I get? 20/2, which is 10. Again, we don't really have room for 0, 10, so we're going to need to extend this line on up quite a ways. Got 5, 6, 7, 8, 9, 10. And so we've got a point way up here that we're going to call B prime. Obviously, we would do this on graph paper if this were our homework, and we would have more room to work it out. Okay, where's point C at right now? You sure could, yeah. I don't know if you guys heard what Tate said, but he said, couldn't you just figure it out by basically going from D prime up to where B prime is and putting a dot? You sure could. Where is C at right now, though? 3, 4. But we already know that 5/2 of 3 was 7.5, and that 5/2 of 4 was 10, right? So where should C prime be? 7.510. So great idea there, Tate. So we'll go from D prime straight up here and meet with B prime. And that's going to be our C prime. And then we'll just connect our dots. Always connect your dots. Sometimes some of you aren't connecting them. You're drawing the shape, so it should be connected. And there's my very bad border. Use a ruler if you're doing it on your homework and make it neat. So dilations, remember the big idea there is it's just you're multiplying by your scale factor. That's all you're doing. Any questions about dilations? What if I wanted to write a rule for this dilation? What would my rule look like? X, Y, arrow, what? 5/2 X, 5/2 Y. Remember that you're just multiplying. That's what that rule tells us. Multiply by that scale factor. All right. So this one is going to be just a little bit different. So it's given that these two triangles are what? Similar. Find the coordinates of point U and the scale factor. I'm going to tell you my advice would be to first find your scale factor, because then it's going to be easier to do the second part, find the coordinates of point U. So I would go in the opposite order. Find my scale factor first and then use it to find point U. If they're similar, what do we know about the ratio of their sides? Or what do we know about the sides? They're proportional. So we know that we should be able to compare any two corresponding sides, and that will give us our similarity ratio or our scale factor. So when I look at this picture, first of all, notice where these coordinates are at. Let's find the lengths of the sides. So what would this distance from 0 over to t be? 9, right? It's negative direction, but when we're just talking about the length of the side, we're just going to put positive 9 because we're going 9 units to the left. What would the distance here from 0 to r be? 12. So everybody following? This is at negative 9, 0. This is at negative 12, 0. So this is a distance of 9. This is a distance of 12. What is the length all the way up here from O to S? 16. So if we're trying to figure out what is the scale factor, we should be able to compare any two sides. We can't use these two because we don't know what O to U is, right? So we can't use these two sides, but we could use these two. All right? Keeping that in mind, which number needs to go on top of my scale factor? Do you remember when we talked about this? When we look at the name of our similarity statement, which figure always goes on top? Not always the smaller one, because it's not always a reduction. The first one. Always the first one. Whichever one that's named first goes on top. Always. Sometimes it's a reduction, which would put the smaller one on top, and sometimes it's an enlargement, which puts the bigger one on top. So you always name the first one on top. So TUO, what's the side length that corresponds to triangle TUO? The 9. TUO is the smaller one, so we're going to put 9 on top. And it corresponds with what side? 9 corresponds with 12. And then reduce. What is our scale factor? 3/4. Any questions on the scale factor? Okay, then to find the distance of this side, you can write a proportion. And every single time, it'll be just like what we did last class period. If you find your scale factor first, that will help you. So you can say 3/4 should equal, and now you can compare the other two sides. So again, which triangle did we put on top? The smaller one or the bigger one? The smaller one this time, because it's what was named first. So what's going to go on top for this side, the smaller side here? X. And what's going to go on bottom? 16. And you may be able to just tell what that length is, but if you can't, cross multiply. So you have 4x equals, which is 48. And then we're going to divide by 4. And what is x? 12. Now it asks you to find the coordinates of point U. So 12 is the distance of that side, but what would the actual coordinates for point U be if this length is now 12? 0, 12. So the second part of the question is, what is point U? Point U will be at 0, 12. Okay, I want to point out two things one more time. First of all, when you're writing your scale factor, which number always goes on top? The first one you're naming in your similarity statement, always. Second thing I want to remind you is we didn't worry about the negatives until it's time to write your coordinates. Then you have to worry about, did you go left or right? Did you go up or down? So if this distance was 12, but we had went down 12, then our coordinate would have been 0, negative 12. Are you with me there? Okay. Any questions on this example? Let's try another one. You guys go ahead and try this one. See if you can answer those two questions. Find the scale factor and find the coordinates, this time of point N. I'm going to give you a couple minutes to try one. So first of all, the difference on this one is they did not put the coordinates on the picture, right? So we first have to put our coordinates on our picture. So we know that P is at negative 15, 0. M is at negative 10, 0. And this point's obviously where? 0, 0. And then N, we don't know, that's what we're looking for. And Q is at 0, negative 30. Okay, so the first thing we want to do is find our scale factor. A scale factor compares two corresponding sides. Dad, please put your book away. So when I look at my picture, which corresponding sides do I know both side lengths? Okay, PM, is that what you said? PM, careful, is just a little piece. It's not one of the sides of the triangle. PO and MO. Does everybody agree that we could find the lengths of those two sides? We do not know ON, we do not know we do know OQ, but we don't know ON. So we can't use these two right sides, but we can use the two top sides. Okay, when I'm going from O to M, how far is this distance? I heard one person say it. Talk to me, make sure everybody's with me. 10, right? We're going negative 10, but we're just going to write down 10 because we're talking about the length of a side of a triangle. Okay, what is the distance from O to P? 15. Again, it's negative 15, but we're talking about the length of the side, so we're just going to use the positives. Which triangle did they name first? MON. So which number needs to go on top? 10. So we're going to say 10 over 15, which reduces to 2/3. Any questions first on the scale factor? Okay, second thing you're going to do is try to find the coordinates of point N. To do that, we're going to compare our side lengths. We'll start with our scale factor, 2/3. You could use 10 over 15 if you want, but it's easier probably mathematically to use our reduced value. So we did small to big, 2 to 3. So now we want to come over here and do small to big. Okay, so do we know this length, this short length from 0 to N? No, so we'll put X. And what's the length from O to Q? 30. Again, it was negative because they went down, but we're not going to worry about the negatives right now. We'll worry about that at the end. So then we're going to cross multiply, and we get 3X equals 60. Divide by 3, and what is X? 20. But now when you write your coordinates, you have to think about, are we going left, right, up, down? So I'm going from the origin down 20. So where does that put my coordinate? 0, negative 20. Questions? Please ask if this is confusing to you on any step of the way. Okay. If you flip it over, I think we're on the back side now. You'll notice the next one is a proof. We're not doing the proof, so you can cross out through that example. And so if you look at this lesson quiz part 1, this is just going back over what we just did. So we're not doing, yes we are. Number 1 is asking you to find the new coordinates after this dilation, and number 2 is asking you to find the points M and the scale factor. So this is like the first example we did, this is like the second example we did. I'm going to go ahead and have you and your partner try these last 2 problems, and then we're going to stop. Okay, this will be the last one we do. Understanding, please ask me so I can make this more clear, okay? We've got a dilation with a scale factor of -4. First of all, I want to tell you that this is really not just a dilation. Dilations are supposed to be positive multipliers, meaning that we would multiply by only positive numbers. So what's happening here is we're going to make this shape bigger, but then because we're multiplying by a negative, that means we're going to take this shape, and not only are we going to make it bigger, but when you multiply both x and y by a negative, if you think back to chapter 4, that means not only are you making it bigger by a factor of 4, but you're making each number negative. Do you guys remember what transformation this is? It could be a reflection. If it was a reflection, it would be a reflection over the x-axis and the y-axis, which is really the same as a rotation 180 degrees. So what they're really doing here is they're enlarging it and rotating it at the same time. Okay, so if you were to actually graph this, it would not look like it just got bigger by a factor of 4. It would be rotated 180 degrees as well. All right, what are my coordinates for x prime? Okay, and all we're doing is multiplying by -4. Y prime? 8, -8, good. And z prime? 8, 0. And again, you're multiplying by a negative, so it changes those negatives to positives. All right, find the coordinates of m and the scale factor. Let's start with the scale factor. Our scale factor, we're comparing the two sides, and we're making sure to put the first one on top. So JOK, that would be this little triangle. We know this distance was 4. This distance was 10. This distance was 2. This distance we don't know. So what did you write down to start with for your scale factor? 4/10. The JOK, it's not always the smallest, even though it has been today. It's whichever one is named first. So 4/10 reduced to 2/5. All right. And then we write our proportion using 2 to 5 to find the distance for the other triangle. So what did you put on top here? Over x, and you should be able to know what x is right off the bat. What is x? 5. If 2/5 equals 2/x, then x has to be 5. So that means that this distance here is 5, but we went down 5. So what does that make our coordinates for point M? 0, -5. Any questions on the lesson for today? That is it. Just dilations, making sure you can find coordinates of points. We hadn't done anything like that before. Okay.